Hello everybody, welcome back to Periodic Trends. We're continuing our series. This is actually the last one in the series about periodic trends. We're going to talk about ionic radius today. But before we get started with ionic radius, we're going to take a look back at what we've done so far. So at the very beginning, I said there's two things you got to look at when determining any periodic trend. That's the Zeph, or the positive pull from the protons, which means the more protons, the greater the pull force, and that increases on the periodic table as you go right. Because what you know by now is, as you move right on the periodic table, the number of protons increase, therefore that Zeph pull force increases also. The second thing we're looking at is energy levels, because the distance from the nucleus matters when we're talking about the Zeph pull force. And what we're really talking about is this atomic radius. And we know as we increase the energy levels, go down one, more energy level, more, that radius just gets bigger and bigger and bigger and bigger. So we get further and further away from the nucleus. And then I said, okay, atomic radius was our first trend. Atomic radius increases as you move left on the periodic table and as you go down on the periodic table. Okay? Remember, it gets bigger as you go left because there's less protons, which means there's less pull power, which allows the electrons to expand out more because they're not being held on as strong. And as you go down, the radius gets bigger because it's just another energy level. It's just that much more bigger. Then we talked about electronegativity, the ability to attract electrons. Okay? We said it gets bigger, it's easier to attract electrons as you go right and as you go up on the periodic table. Well, it gets easier to attract electrons as you go right because you have more protons. The more protons you have, the more pull power, that's Zeph. So it gets easier and easier to pull electrons. As you go up, it's actually a smaller atomic radius. Therefore, you're closer to the nucleus. The closer you are to the nucleus, the easier it is to hold on and grab electrons. And then the last video, we looked at ionization energy, the energy required to pull off an electron. And we saw that it requires more energy, or it gets harder to pull off an electron as you go right because there's more protons. They're holding on to the electrons a lot stronger. Therefore, it's harder to pull off these electrons as you go right. As you go up, same thing. You're getting closer to the nucleus. Okay? The closer you are to the nucleus, the closer you are to those protons. Therefore, it gets harder to pull off those electrons. Okay, so today we're going to be talking about ionic radius. Ionic radius is the radius of an atom after you have lost an electron. Okay? You can also say it's the radius after you've gained an electron also, because you can get an ion when you gain electrons. So this kind of takes us back to PIN and all that stuff, protons, electrons, neutrons that you talked about earlier. And what happens here is if you lose an electron, right? If you lose an electron, you take on this positive charge, right? We call this positive charge a cation. Okay? And when you gain an electron, you take on this negative charge, and we call this an anion. Okay? So when you lose an electron, you take a positive charge. When you gain an electron, you take on a negative charge. And those are called cations and anions. Okay? So let's get into ionic radius. So let me give you an example here. Let's say we have, I don't know, magnesium. Okay? Magnesium here on the periodic table, let me bring it down. Magnesium here is on the third energy level, and he has 2 valence electrons. Okay? So if I was to draw magnesium, Mg, with 3 energy levels, 1, 2, 3, and then I'm going to put in his electrons. Okay? Put in his electrons, so that one has 2, this one gets 8, And the next one, that's 8, 9, 10, 11, 12. So 12, so that's 2. There you go. That's magnesium, okay? Now, let's say magnesium loses an electron, right? Boom. This electron right here is gone, okay? That electron left. Now, what we see here is we go from magnesium, we go from regular magnesium to magnesium. Say he lost an electron, right? So what charge is he going to take? We go to magnesium with a +1 charge, right? With a +1 charge. So when you see this, this is regular magnesium. When you see this, that means magnesium lost 1 electron, okay? And now you can actually go one more, because magnesium can also lose a second electron. He can lose this electron down here. That electron can go away. And then we have a second ion of magnesium with a +2 charge, which means he lost 2 electrons. Okay? So I'm just going over the vocabulary and so you know what's happening here. Okay? So let me do some explaining now what ionic radius is. Ionic radius, we have our nucleus here, right? And it's full of these protons. Okay? Our nucleus is just chock full of protons. Has 12 protons in here. Now, these protons have a pull force, that Zeph we've been talking about all week, right? These protons pull on all the electrons. Okay? Now, here's the thing. It's a set amount of pull force. So, the nucleus is actually holding on to this electron. But if that electron leaves, what do you think happens to all the energy that was being used to hold on to it? Well, that energy gets redistributed to the remaining electrons, which means those electrons are being pulled with even a greater force. And if I pull you with a greater force, all these electrons are going to contract in. So what's going to really happen is we went from this orbital to, let me redraw magnesium in his little cores, maybe to something like this, okay? Because now he has these electrons right here, okay? So this outer energy level that these 2 electrons were in is kind of fundamentally gone. So now we can pretend that this energy level isn't here. And now look at the radius. We went from a big radius from here to here to a smaller radius from here to here. So what happened to the radius when we lost electrons? The radius got smaller, right? The radius got smaller. Okay? The radius got way, way smaller. And on the flip side, if you gain an electron, right, there's not, if we're right here, let's go back here, or actually just let me draw a new one here. Let's say I have oxygen, for example, right? Oxygen has his 8 electrons, 8 protons, and his 2 energy levels. He has 2 here, that means he has 6 left. 1, 2, 3, 4, 5, 6. So this goes back to when we were talking about is it easier to gain or lose? In this case, he needs to get 8 in here, so it's actually easier for him to gain 2 more than to try to lose 6, right? So when oxygen gains an extra electron, blue, 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 an electron comes in and sets up shop right here, right? He gained an electron. Oxygen goes from an oxygen to oxygen -1 because he gained an electron, right? But here's what's happening here. When these protons is distributing its energy to all these electrons here, right? Well, when this new electron comes in, it has to have energy to give to that electron, this pull force, so it can hold on to it. Well, where does it get that pull force energy from? Well, it has to take a little bit from all these guys to be able to hold on to him. So what's happening is the protons are redistributing this pull force, so everybody's getting pulled just a little less so that this new electron can be held onto. So if you get held onto a little less, what happens to your radius? Your radius gets slightly bigger. Okay? Your radius will get slightly bigger because the pull force isn't holding on to the electrons as strongly as it was. Okay? So when you gain an electron, your radius gets bigger, and when you lose an electron, your radius gets smaller, right? So let's add this to my notes right here. When you gain an electron, your radius gets what? Bigger. When you lose an electron, your radius gets smaller. Those are important notes right here. These two are important notes. When you lose an electron, you take a positive charge, it's called a cation, you get a smaller radius. When you gain an electron and ions, you take a negative charge and your radius gets bigger. Okay, that's super important notes there. Okay, so I'm going to square this off to let you know that's important. Okay, you need to know that. Well, how does this go with the ionic radius? Okay, how does this go with the ionic radius? Well, it actually goes the same as regular atomic radius, right? If you pulled off one electron from every element, everybody would shrink accordingly, right? Everybody would shrink accordingly. And if you gained one electron with every element, everybody would grow accordingly. So the trend actually remains the same. What's the trend for atomic radius? Well, we know the trend for atomic radius is as you go to the right of the periodic table, right? This is the trend here. We're looking at the trend right now. As you go right on the periodic table, we get smaller. As you go down on the periodic table, you get bigger. I said that completely wrong. You don't get smaller, you get bigger. Right? It gets bigger because there's less protons and it can't hold on to it as much, so it expands. And it gets bigger as you go down because you're just outright adding energy levels to it, right? So excuse my mistakes here. And just know that this is the trend also for ionic radius. But the big thing you need to learn for ionic radius, outside of this trend, is this right here. When you lose an electron, you take a positive charge, you could become a cation, and you have a smaller radius. When you gain an electron, you take a negative charge, it's called an anion, and your radius gets bigger. So, let's do a quick recap on all the periodic trends. Okay? All the periodic trends. We're going to come back here. We have atomic radius. It increases as you go left and down. We have electronegativity. It increases as you go up and to the right. And we have ionization energy, and it increases as you go up and to the right. And finally, the last one we can add to this is what? Ionic radius. And all ionic radius means is it's the radius after you have lost or gained an electron from the neutral atom. Okay? So the trend here is it's the same as atomic radius. It increases as you go right on the periodic table and down on the periodic table. But the real things you need to memorize is when you gain an electron, you take on a negative charge, right? A negative charge, and we call that an anion. And when you gain an electron, your radius gets bigger. Okay, that's the big part right there. When you gain an electron, you take on a negative charge, we call those anions, and your radius is going to get bigger. When you lose an electron, right, you take on a positive charge, we call those cations, and your radius gets smaller. Okay, so those are the two important key facts here. And guys, it's not hard when you're doing these atomic radiuses. It's actually pretty simple. So let me give you an example here. If I have a magnesium, okay, if I have a magnesium and I'm comparing it to a magnesium plus 2, right? Well, what does plus 2 mean? Plus 2 means you what? You lost 2 electrons, right? If you go back to your notes here, positive means you what? Lost 2 electrons, right? Positive 2 means you lost 2 electrons. So what's going to happen to the radius of this guy? It's going to get smaller. So that means he has the smallest radius. Okay? Which means he has the biggest radius when comparing. Okay? Now let's look at something like sulfur. If I have sulfur and then I have sulfur, let's say -1, which one's bigger? Okay? Which one's smaller? Well, let's look. What does negative mean? Negative means you gained an electron, right? And your radius gets what? Bigger. So -1 means you gained 1 electron, so that means he got bigger. Which means this guy has to be smaller. Okay? What if I had an S with a -2? That means he got even bigger because what? He gained another electron, right? -2, negative means you gained an electron, right? Up here. So I gained 2 electrons. That means my radius should have got even bigger. Even bigger. Okay? So all you have to do, guys, when you're doing examples with ionic radius is understand this part right here. Gaining an electron, you have a negative charge, and ions, the radius always gets bigger. When you lose an electron, you take on the positive charge, cation, and your radius gets smaller. Guys, this is periodic trends, and I hope you can use this information. If you need to, write some of these notes down, the basic trends and what's required. It's literally everything on this sheet right here. Go back, rewind, and take a look at this entire sheet to get, guys, have a great day.